Bismillahirrahmanirrahim. Last time we spoke about the index number. We said that the index number measures the value of one item or a group of items at a certain time to another time to see whether the price or whatever the value of the item is increased or decreased. And we said that we have two types. We have simple index number or simple price index number, which measure the value of one item, and we have aggregate index number that measures the group of items. For today, we are going to speak the unweighted aggregate price index number. For the simple index number, we said that for the first type, simple, was I t equal to p t divided by sub 0 multiplied by 100. This was the simple index number, where bt is the value of the given time and p sub 0 is called the price at the base time, or the base period. For today, we are speaking about the unweighted aggregate price index, which is computed as UIT equals sigma of PT divided by sigma of PI 0 multiplied by 100, where BIT the price of item I at time t and B sub I0 is the price of the item I at the base period. For example, let's have this one. The table below shows the prices per pound for three fruit items from 1980 to 2005. We need to calculate the unweighted price index for 1985 with base year 1980. We're speaking about aggregate, unweighted aggregate price index. So just direct application for the formula, which is this one. I need to find index of PIT. And the time given in the question is 1985. This is t equal to, so PIT, we look for the 1985 and sigma, which means we need to add these prices, apples, bananas, and oranges. So it is 0.684 plus the price for bananas was 0.367 plus the price for the oranges, which is 0.533, and sigma of the I0, the price is at the base time. Base time is 1980. So this is a V0. That will be 0.692 plus 0.342 plus 0.365. Just add these two series of values will give me, first one is 0.684 plus 0.367 plus 0.533. The first one will give me 1.584. The second one, 0.692 plus 0.342 plus 0.365 will give me 399. So the unweighted UI at 1985 is equal to sigma IT divided by sigma B sub 0 or I sub 0 multiplied by 100, which is equal to 1.584 divided by 1.399 multiplied by 100, which is equal to 1.584 divided by 1.399, which is equal to 1.13. Or, okay, multiply by 100. It is 113.2. This means the price has increased by 13%. This is the meaning of the price index number. We are just comparing the price for the aggregate for a basket of items to the grouped or group of items. This is different from the simple index number or simple price index number that will be compared the value for only one or for a single item. For the aggregate, we are speaking about group. It is like one basket and we compare the price at the given time to another one. The second one, we need to calculate the unweighted price index for 1995 with base 1980. So for this one, number 2, VIT, or let's say 1995 is equal to, take the price for 1995, that will be 0.835 plus 0.490, we are adding these numbers, plus 0.625, which is equal to 0.835 plus 0.490 plus 0.625. That is 1.95. So in this case, because we are using the same base number, the unweighted UI at 1995 equal to 1.95 divided by the price for 1980, which is we found it before. This is for base 1980. So divided by 1.399 multiplied by 100 is equal to 139.4. So this means the price was increased by 39.4%. For the last one, we need to calculate the animated price index for 2005 with base year 1980. So this time we are finding the price for 2005. That will be, let's find the sum for this one, 0.966 plus 0.838 plus 0.490. That is 2.294 for the third one, for the third part, and to find sigma of bi at 2005, which is equal to 2.994. And we are using the same base year, which is 1980. So the unweighted index number or aggregate index number will give me, which is 2.994 divided by 1.399 multiplied by 100, which is equal to 1.399. So 0.994 divided by 1.399 is equal to 214. It's 240, which means the price was increased by 114%. So this is the idea of the aggregate price or unweighted aggregate price index number. Just to compare value of group item at given time to another time, 2005 to 1980, to see or to check the prices were increased by how much. The other type of this index number is called the weighted aggregate index number. So the first one was unweighted. For the second one, we have weighted aggregate index number, and we have three types of weighted aggregate index numbers. The first one for the last year's price index, which is computed as sigma of PIT times Q, the quantity multiplied by the price. And that's why we call it the weighted. We multiply the price by the quantity. At a given time divided by the price or prices multiplied by the quantities at base time. PIT, the price of item at a time or at time t. PI0 is the price of item I at the base period, and QI0 quantity of item I at the base period. So we can see for the last year's price index, we are using the quantities of the base time, up and down. This is the difference between this weighted and unweighted. For the unweighted, we just find the sigma of PIT divided by sigma of I sub 0 or sub I0. If we multiply by the quantities, we are finding the weighted aggregate index number. For example, let's have this example now. The table below shows the prices for 3 fruit items per pound for the years 1980 and 2005 and their corresponding quantities. We have apple, we have bananas, and we have oranges. The prices given there with the quantities. This is the base period, and this is a BT. We can say this is B0 and this is Q0, and this will be the BT. The base time is 1980 and the time given is 2005, and we need to find or to compute the last best price index for the year 2005 using 1980 as base period. So the base period is 1980 and the time we needed is 2005. Now I have PI0 given there. That is for the apple we have 0.692. 692. For the banana it is 0.342 and 0.365 for the orange. QI0 is given there, it is 19.2. 20.2 and 14. PIT 0.966, 0.838 and 0.490, and we need to find PI0 multiplied by QI0 by this one. Then we need to find PIT multiplied by QI0. We are using the quantity at the base time. So just multiply PI0 with QI0. The first one is 0.692 multiplied by 19.2, which is equal to 13.29. Next one, 0.342 multiplied by 20.2, that equal to 6.991. Next one is 0.365 multiplied by 14.3, which is equal to 5.22. Now for the next one, we need to multiply PIT with QI0. That is 19.2 multiplied by 0.966. That will give me 18.55. I'm multiplying this with this one. Next one, $20.2 multiplied by 0.838, equal to 16.93. Next one, we have 14.3 multiplied by 0.490, which is equal to 7. Now let's find the sigma for these numbers. I need to find the sum. So sigma of I0 is equal to, I have 13.29 plus 6.91 plus 5.22, that is 25.42. 25.42. The next one, I have 18.55 plus 16.93 plus 7 is equal to 42.48. So let's be just in this number now. LPIT BIT is 2005, which is equal to the sum of BI 2005 multiplied by Q I0 divided by sum of BI0 times Q I0. This is equal to 42, or multiplied by 100 there. 0.48 divided by 25.42. This will give me 25.48 equal to 166.7, which indicate that the price was increased by 66.7%. This is the Lesbia's index number, or the Lesbia's price index number. Find the sigma of BIT multiplied by the quantity at the base time divided by the prices multiplied by the quantities at the base time multiplied by 100. Will give you the increase or decrease in the prices of a group items. The second one we have, it's called the passive price index. It is computed by, it's the same principle, but in this time we are using the quantity at the given time, not at the base time. It is P of IT multiplied by QIT divided by BI0 multiplied by QIT multiplied by 100. So we are using the quantities at the given time. For example, if you want to use the same one that we did before, use the data example 1 to compute the past or passive price index in 2005 using 1980 as a base period. So we are using the quantities at given QIT. In the Lesbia's price index number, we use the quantities at the base period, but for this one, we are using the quantities at the time given, not the base time. So in this table, we use the same data in the first example, and we found B IT multiplied by QIT and PI0 multiplied by QIT. We use the quantities at 2005. This is quantities at 2005, not 1980. So the index number for this, or the batch index number, PIT, which is equal to We need to find the sum of these numbers, sigma. So for quantity at the 2005 is equal to, I have 15.4560 plus 22.4584 plus 5.1940, which is equal to 43.1084. This is the sigma of these numbers. For the base time, we have 11.0720 plus 9.1656 plus 3.8690 is equal to 24, or this is equal to 24.1066. So the batch index number will be 43.1084 divided by 24.1066 multiplied by 100, which is equal to 43.1084 divided by 24.1066. That will be 178.8, which means using this index number, we can say that the prices were increased by 78%. So using this one, you can say that the price of this basket, which is contain apples, bananas, and oranges, was increased by 78.8%. This is the I of the batch index number. For the lesbians, we use the quantities at the base time. For the batch, we use the quantities at the given time, 2005. The last one, this one. The last index number is the Fisher's price index, which is computed using that the square root of lesbians multiplied by the batch index number. And this is an example just to show the idea. Use the results for on example 1 and example 2 to compute the Fisher's price index number. We use the first two examples just to compute the Fisher's price index number, which is equal to the square root of lesbians multiplied by batch. And what we have that time, we have 167. This is the lesbians multiplied by 178.8, and we will get 172.9. And therefore, the Fisher price index is 172, indicating that the cost of purchasing these three items in 2005 was 72 more than in 1980. So this is the idea for the index number, unweighted or weighted aggregate index numbers. We just use these tools or measures to compare the prices in two different times. One of them is called the base time. The other time is the one that we need to find or to check the price whether it is increased or decreased, comparing to certain time in the past. So this is the idea of index price numbers or price index numbers.